Hello everybody and welcome to section 6. After we know how to create 3D models and how to modify them, now it's the time to talk about assembly design. Here we will learn how to access the assembly environment and we will get introduced to the user interface. To create an assembly file, select New and instead of Part, select Assembly. And here hit OK. If this is the first time you create an assembly file, SolidWorks assumes that you want to import or insert one of the parts you already created. That's why select Cancel for this and select Cancel for this. In the assembly environment, we are interested in two main tabs. The first one is Assembly. Here we can insert components and then we can define mates between them so we can connect them to each other. We can pattern components and we can mirror them. And then we can move components, we can rotate them, and we can explode views. And the other important tab is Evaluate, where we can use the Measure tool and find the mass properties, and then we can check the interference. So basically, we will use Evaluate and we will use Assembly. Before inserting part into the assembly, we need to create some parts so we can insert them. To do so, select New, and select Part, then OK. And here I will start with a sketch on the top. And let's create a 400 millimeter square. Then let's extrude this to 100. Once done, we need to save this part, and I will call it Assembly Part 1. Then create a new part, and this time create a 100 millimeter cube. The same way, let's save it, and this time I will call it Assembly Part 2. Now, if you go to Window, you will find Assembly 1. And here we will insert the first part. To do so, we have this option, Insert Components. If you open this menu, you will find many options. For now, we are interested in the first one, Insert Components. And here you will have all the files you kept open. If you can't find the files here, select Browse, and then select the part. Let's select Assembly Part 1. Move the mouse, then click, and the first part was placed. Now, if you have a lock here, it's a little bit different from what we already saw in the part design. Here we have this icon, and as you can see, it's yellow and blue, which means we have two parts, which indicates an assembly file. For the part file, we only have this yellow part. Now, we have the small letter, which is F, which means fixed. As a quick review, any part in the 3D space has 6 degrees of freedom. It has 3 translations along the X, Y, and Z, and it has 3 rotations about them. So our task in the assembly design will be to eliminate these degrees of freedom. And that can be achieved by using the mates, which are basically relations between the parts, like parallel, perpendicular, and coincident, and so on. We will talk about them in detail in the coming videos. For now, we can tell from this letter here that this is a fully defined body, and you can tell that from here, fully defined. So this is how we insert our first part. Next, we will talk about coincident relation. Coincident mate. Before talking about coincident mate, we need to insert the second part. To do so, select Insert Components, and then Browse, and from here, select Assembly Part 2. Click anywhere you want, so this cube is placed. As you can see here, we have this negative sign, which means this part is not fully defined. And here, you can tell that it's underdefined. Now, our task will be to eliminate the 6 degrees of freedom that this cube has, so it will become fully defined. Now, this body can translate on the X, Y, and Z. Like if I click and hold, I can move it on the X, on the Y, and on the Z. And at the same time, it rotates about all of them. So our task will be to eliminate all of these degrees of freedom. Now, I want you to imagine something before we start talking about the mates. What if I want this face to be all the time coincident with this one? If I want to maintain this relation, like if I have this view, as you can see, this face is coincident with this one all the time. If you move this up, down, it will be always the same. So what degrees of freedom were eliminated? Here, I cannot move this to the left and to the right because this will break the relation I just created. That's why I already eliminated the translation on the Z. So now I have 5 degrees of freedom. Now let's talk about the 3 rotations we have. The first one is the rotation about the Y. If I select about entity, so this edge goes along with the Y, and now I cannot rotate this cube, because rotating the cube will break the relation I just defined. So that's why I lost the 2nd degree of freedom here. Now, let's talk about the rotation about the X, which is represented by this edge here. If you select this edge and try to rotate it, it won't rotate, because this rotation will also break the relation I just defined. So I already lost 2 degrees of freedom of the rotations. Now, the 3rd rotation is a rotation about the Z. So if you select this edge, now you still can rotate this cube, but see how this relation we created is still maintained. That's why this face is always coincident with this one, even though I can rotate it about this axis. So basically, we are talking about 2 rotations and 1 translation. So now, this cube has only 3 degrees of freedom. So our task will be to eliminate them. So, if I go back to this view, as you can see, I can move it up and down. The way to eliminate this motion is having this face coincident all the time with this face. And in this way, it won't move in this direction, which is the Y direction. Now, keep in mind that we still have the first relation we defined, which is the coincident between this face and this one. Now, which kind of motion that this cube can perform? It only goes this way and this way. It cannot go up, because we already defined another relation. Now it only translates in the x-axis. So how can we eliminate this motion too? We have many options. For example, we can set this face to be coincident with this one, or we can set this face to be coincident with this one, and the result will be the same. So now if I have this face coincident with this one all the time, now you no longer can move this cube. And look here, we have fully defined. And here we no longer have the negative sign, which means that this body is fully defined now. So this was an indirect way talking about the coincident relation. Now let's talk about it in more detail. If I insert the same component once again, and select mate, and here you find coincident, and then you can select many things. The first one is to select face and face. You can select edges and you can select vertices. For face and face, as we already did here, you can select this face and this one. Now, if you're not happy with this alignment, if you want it to be flipped, you can simply select anti-aligned, and here it will be the opposite, but it will be the same relation. If you hit OK once again, you can find mates here, open it, and you can find the relation you just created, listed the last one. Now I will suppress this mate, and let's try something different. You can select coincident, and this time you can select an edge with an edge. And here, let's see what happens. Now you cannot separate these edges, but you still can rotate it about the x-axis. Even if you drag it here, it will be along the extension of this edge. As you can see, it will be there all the time. Now I will suppress it once again, and you can use vertices. For example, select this vertex and select this one, and here they will be coincident all the time. Wherever you move this cube, the relation will be maintained. Now suppress this one, and you can select this vertex with this edge, and here it moves along this edge and it rotates at the same time, but it will always be along the edge extension. So basically, this is what we need to know about coincident relation. In the next video, we will talk about other types of mates. Other mates. In SolidWorks, mates are not limited to coincident. We have many other types. Let's go through them one by one. Before doing so, make sure to suppress this mate, and now we have this cube free. Then select mate, and here we have parallel mate. What parallel does is that it makes faces parallel to each other even though they are not in contact. For example, if I select this face and this one, now they are parallel to each other, but they have no contact. You can move this everywhere, but this face will always be parallel to this one. Try to drag it anywhere. These faces are always parallel. Now you can apply another one, for example, between this face and this one. And here you can drag it, but these relations will be maintained all the time. Make sure to suppress these mates and select mate once again, and we have perpendicular. This mate makes faces perpendicular to each other. For example, if I give this some angle like this, and now select mate and select perpendicular, and here if I select this face and this one, then hit OK, and here as you can see, this face will always be perpendicular to this one. You can apply it once again with different faces, like this one and this one, and here it's perpendicular too. Finally, you can select parallel between this one and this one, and here the three mates were achieved. The first one is perpendicular, and it's obvious that this face is perpendicular to this one. The second one is perpendicular too, so this face is perpendicular to this one, and the last one is parallel, which means this face is parallel to this one. Another important mate is distance mate. For example, if I would like to control the distance of this cube after defining these mates, you can select mate, and here you can define distance, and let's say 200, and then simply select this face and this face. Now the distance between them will be 200. Let's select 200 once again, and then select this face and this face. So now the distance between this face and this one is 200, and the distance between this face and this face is 200. And here you can select this mate and you can see the distance, and you can select this mate and you will see the other distance. Another important mate is angle. Now let's insert this cube once again, and here select mate and then select coincident, and then select this edge with this edge. Now as you know, this cube is free to rotate, so let's define an angle. So select mate and then select angle, and here select 60, and then you can select this face and this one, and this angle will be fixed all the time. If you select it from here, you can see the angle, and then if you try to rotate this cube it won't rotate. Now, let's go back to this feature. And here you can flip the alignment. You can select aligned, or you can select anti-aligned, and this will change the position of the angle. Now hit OK. The other two mates we will talk about are connected to shapes that have curves or cylindrical surfaces. Now, if we want to modify this part, we can simply select it from here, and then you will find Open Part. Now, select this face, start a sketch, and let's draw a hole. And let's set this to 200. And then select Extruded Cut, and through all, then hit OK. And let's go back to the assembly. When you have this message, select Yes. And as you can see now, we have this hole. Now, I will select these 3 cubes, and then I will suppress all of them. And here I will create another part. I will start a sketch on the top. I will simply draw a circle and give it a diameter of 100, and also give it a height of 100. After that, start a new sketch on this face, and let's draw a square. Don't worry about the dimensions of the square for now. Just give it some height, let's say 25. And here we have this shape. Let's save it, and we will call it Assembly Part 3. And let's go back to the assembly. And let's select Assembly Part 3. Now, select Mate, and here we have Concentric. Select Concentric, and simply select this cylinder with this hole. And notice how the center line of this hole is coincident now with the center line of this cylinder. But I still can move it in this direction, and I still can rotate it. Now, to eliminate the rotation, we can simply select Parallel, and then select this face with this one. Now, they will be parallel all the time, and that's why you will not be able to rotate it. Then, we still have the problem of this translation. To solve it, you need to select Mate once again, and let's define a distance of 150 millimeters, and then you can select this face with this one. Now this part is fully defined. Now let me select these 3 mates once again, and then suppress them. Select Mate, and here you will find Tangent. Select this face. For example, you can select it with this one, but this time let's select it with this one. And then select Anti-Aligned, and here, as you can see, this face is always tangent to this one here, but you can still move it up and down, and you can rotate it. So the way to eliminate these degrees of freedom is the same. We can select Parallel, and then select this face, and select this one. And this way, these 2 faces will be parallel all the time, and that's why this part will not rotate. Now we need to eliminate this motion up and down. For example, I will select Coincident, and then I will select this face with this one. And here, I still have only one type of motion, which is this one. And for that, I can select Tangent, then select this face and this one. And notice how the extension of this face is tangent with this one. So this is what we need to know about tangent and concentric. One last option I would like to talk about in concentric is that we have the option to eliminate the rotation. If I select concentric, I can select this face and this one. And here I have this option, Lock Rotation. Select it, then hit OK. And now this part doesn't rotate. It only translates up and down, and you can eliminate this by selecting coincident between these faces, for example. And here we go. Before ending talking about the mates, it's very important to say that using mates is not limited to these surfaces. We can use it with the planes. Now, in the assembly environment, we have 3 planes for the assembly itself, and each part of these has its own planes. That's why we can relate bodies using these planes. Let me show you an example. Now, I will show these planes, and for the last part I inserted, I will show the planes, and don't forget to show them from here. Now, if I select mate, for example, coincident, I can select this plane with this plane to be coincident. And then, if I drag this, then once again, I can select this one with this one to be coincident. So, as you can see, it's not limited to the parts. You can use the planes too. So, this is what we need to know about assembly mates. Next, we will talk about linear pattern. Linear pattern. Linear pattern in the assembly environment is very close to the linear pattern in part modeling. That's why let's start with a new assembly file. And here, let's insert assembly part 1 once again. If you still have the hole here, don't worry about it, it's okay. But before talking about the pattern, let's talk about the placement of this component. Always the first one. So instead of having it fixed, I will select float, and in this way we have this negative sign, which means this is an underdefined assembly, as you can see here, so you can move it. Now the problem with fix is that it fixes this part wherever it locates on the screen. Like if it's here, you can fix it, but notice how it's far away from the planes of the assembly. Now, to solve this problem, I want it to lie right in the middle of the assembly file. To do so, select mate, and then we have the origin of the assembly file, select it, and open this menu and select the origin of this part. And now, when the two origins are coincident, we have this option, align axes, which means the x-axis of the assembly file will lie on the x-axis of the part file, and the y on the assembly file will lie on the y of the part file, and the same goes with the z. And in this case, it will lie in the middle of the working space, like here. Now, if you select these planes, the assembly file planes, you can tell that they are very close to the part, which means it lies in the middle. Now, let's open this part once again, and here we need to modify this dimension. Let's set it to 1000, and we need to save it this time, and let's go back to the assembly file. Here we need to insert the cube once again, assembly part 2, and now we need to define some mates. So I want this face to be coincident with this one, and I want this face to be coincident with this one, and finally I need to drag this a little bit here, and then I want this face to be coincident with this one. And here I have a fully defined cube, and you can tell that from this note here. Now when it comes to the linear pattern, we need to select the first direction as we did earlier, and we need to select component. As you can see here, we only can select components, which means we can select this cube, for example, and for the spacing, let's say I want this to be 150, and you still need to define the number. We can flip this direction, so we have it here. Or alternatively, you can select up to reference, and I want to pattern this cube up to this face here, and I want to select a reference on the cube. I want this face, and I want it to get up to here, and I'm interested in 6 copies of this. Now we have this component patterned. As you can see, it's the same as what we did in the part modeling section. Now you can find this pattern here, and here you can modify it. For example, if I'm interested in direction 2, you can select this edge, and you can increase the number here, and so on. So what applies in the 3D modeling applies here. The only difference is that you can only pattern components or parts. And finally, you can skip some instances, for example this one and this one, then hit OK. And here we have the pattern in the assembly environment. Next, we will talk about circular pattern and mirror. Circular pattern and mirror. Circular pattern and mirror are very close to what we saw in the part modeling. The only difference here is that we are talking about mirroring and patterning parts. Let's start with circular pattern. First, make sure that you placed this plate, and let's double check the dimensions. So this is a square, and it's extruded with 100 millimeter. Then we have coincident, and here we chose the origin of the assembly and the origin of the part. Now open this part, and let's create a hole right in the center of this square. And don't worry about the dimension for now. Then select extruded cut, and here select through all. And once done, make sure to save the file, and then let's go back to the assembly file. Here we need to insert the cube once again, and then we need to apply some mates. So I'll select coincident between these faces, and once again between these faces, and finally drag this a little bit here and select this face with this one. Now we have this cube placed. Then go to linear component pattern, open this menu, and you will find circular component pattern. For direction 1, you simply select this hole, and the axis of this hole will be used as the axis of revolution. Then let's set this to 360, and the number, let's increase it to 4. And for the components, let's select this one, and once again make sure that this is 160. As you can see, we have 4 components. The angle is 360, and they are equally spaced. You can increase this number and notice the change of the arrangement. So basically, this is the same as what we earlier saw. And you can skip some instances, then hit OK. And this is how we use circular pattern in the assembly environment. Now, let's talk about mirror items. Open this menu once again and select mirror components. And here you need to select mirroring plan. In this case, I will select this face. And for the components to mirror, I will select this cube and this one. And then hit OK. And here you have these components placed. So it's almost the same, but the only difference here is that you select components, not features. Next, we will talk about exploded view. Exploded view. Later on in this course, we will talk about detailed drawing. And when you create an assembly, some parts will not be visible. That's why we use what we call exploded view. Basically, you drag the components away from each other so they can be viewed easily. To do so, I have this plate and I have this cube, and here I will just select circular component pattern. I'll select this hole and for the component I will select this one, and I need 4 copies. Then make sure to have the angle 360 and equal spacing. Then hit OK. And now I want to drag these a little bit away from this plate, but I will keep the mates I created here. To do so, simply select Exploded View, and here you need to select the component. For example, I will start with this plate, and here you can drag it on the XYZ, or you can rotate it about any of them. For now, I'll drag it in the Y. Then I will select Done. And after that, I will select this component. I'll drag it here, then Done. Then this component, and I'll drag it here, and Done. Then this one, I'll drag it the opposite. And here you can define the distances if you have accurate values. And finally, I'll select this cube, and I'll drag it here. Once you're done with these, hit OK. And now, as you can see, we have nothing moved. We can go to Configuration Manager, and under Default, if you open this arrow here, you will find Exploded View 1. Double-click this view, and here you have all the parts away from each other. You can right-click here and select Animate Collapse. You can control the steps individually, or you can play it all at once. So when we talk about detailed drawing, we will see how this is beneficial. But for now, it's very important to be able to create exploded views. Next, we will talk about interference detection. Interference detection. We already talked about interference detection in part modeling. Now, let's talk about it in the assembly environment. Here, we don't have any interference. That's why we need to insert a new component, and we should have some interference on purpose. That's why select Mate, then select these two faces, and here, as you can see, we have some obvious interference. Now, if you go to Evaluate, you will find interference detection. Select it, and here you can tell that the assembly was selected. Then you can select, and as you can see, SolidWorks highlighted the volume of the interference. This is a very important check we need to perform whenever we create an assembly. This completes this section. In the next section, we will talk about detailed shop drawing.